In object-oriented languages, you often have arrays of your own custom objects, not just arrays of simple numeric or even text values. By default, there's usually no problem creating an array of custom objects. But if you then ask that array to sort those objects using the built-in sort functionality in the language, it simply won't know how to do it, because you need to provide a little more information before you can write the equivalent of myArray.sort and have that work. Because if we have, for example, an array of employee objects with each one containing multiple properties, multiple pieces of data like employee ID, first name, last name, hire date, department, well, what does it mean to sort employee objects? If we want to sort these, should we just look inside each object and sort them by employee ID? Well, that might work, but if you're using this data structure to build an employee directory, you'd probably prefer to sort by the last name ascending. And then within that, you'd want to sort by the first name. And if two people had the same name, you might then want to order by the department or the hire date. So you want to be able to control how these are sorted using whatever you decide is meaningful in your definition of employee. Now, that might sound like you need to write your own sorting algorithm, but thankfully that's not the case. What you will need to do is provide a little bit of code, just a little bit of logic, usually only needs a few lines, and it's typically called a comparator, or compare function or compare method. And this is not sorting, this is comparing. There's a big difference. Sorting is hard, comparing is easy. A comparator or compare function just needs to be able to take any two of your custom objects, employee A and employee B, let's say, and have a little bit of logic that says, is A less than B or greater than B or equal to B, with whatever that means for us. So this example would first compare the last name property of each object. If they're equal, it would then compare the first name. In my simplified example here, if the first name and the last name are equal, it will just say these objects are equal to each other. For our sorting purposes, it wouldn't matter what order they're in. But this little bit of logic expressed in your language would be enough to let any built-in sorting functionality in your language's arrays or other data structures now be able to sort arrays of your objects. Because if it's been told how to compare any two objects, it then knows how to go through and sort 1,000 of them. Now, you'll find these all over the place. Comparators aren't just for arrays, they're useful in many other places, and we'll see the same idea used in other data structures.